Let's talk about the volume of prisms and cylinders. The volume of a three-dimensional figure is the number of non-overlapping unit cubes of a given size that will exactly fill the interior. Basically, it's how much water would it take to fill up this prism. So if you look here, the volume for a prism is simply area of the base times the height. So if you have a rectangular prism, the area of the base is length times width. If you have a cube, you could also write it as s cubed, since it is the length times the width times the height. Let's look at some examples. We want to find the volume of this right regular hexagonal prism. So remember, when we were using our highlighters, let's highlight what we are trying to find and what we are given. And then we're also given this information here. So now let's make our list. To find the volume, according to the formula chart, it's area of the base times the height. Well, we got to look and see what shape is our base. Well, here it is a regular hexagon, so looking at your formula chart, we need to substitute in the formula for the regular polygon, which is where you need your second color. So remembering, we know the height is 12, and since we have a second color here, we need to do our side work. Remembering that A is our apothem, P is our perimeter. So if we draw this hexagon, we need to find our apothem, which is this right here, this dotted line. So 360 divided by 6 gives us the central angle is 60 degrees. The apothem cuts it in half, so this is 30 degrees. That does create a 30, 60, 90 triangle. So let's pull that aside so we can make it a little bit bigger. Remember, across from the 30 is x, across from the 60, and across from the 90. Now we know that if the whole side length is 9, half of it will be 4.5. So that means that this side here is 4.5 square root of 3. This, remember, is our apothem, which is what we need for our area of the base. So now we can substitute in remembering to keep everything in exact terms. The perimeter, 6 sides, all 9 feet long, means our perimeter is 54 feet squared, or sorry, 54 feet. So when we simplify this, we have 121.5 square root of 3 square feet for the area. So we can now take that and substitute in up here. We can multiply the 121.5 times 12, which gives us, or type it all in the calculator, and we get approximately 2,525.3 cubic feet. Since we are volume, we have 3 dimensions, so we got to make sure that our units are cubed. So the volume of this hexagonal prism is this right here. Remembering to highlight what you're given and what you're trying to find, use that second color to substitute in the formula, and if you use the second color, you need to do your side work. Now this next one is finding the volume of a triangular prism with a height of 9 yards, whose base is a right triangle with legs 7 and 5 yards long. So now let's apply this. Let's say we have a swimming pool that's a rectangular prism. We want to estimate the volume of water in the pool in gallons when it is completely full. But then we also want to find the density of the water and to estimate that weight of the water in pounds. So here we are, we're trying to find, number 1, the volume of the water in gallons, And we want to estimate the weight of the water in pounds. So we have two parts to this question. We are given that it's a rectangular prism. We're given our conversion here. And we also are given that the density is right here. Here's our length, our width, and our height. So let's find out these two questions. The volume of a rectangular prism is area of the base times height. Shape of our base is a rectangle, so we have to insert the base times height for a rectangle, and then another height. Now remember, we have two different h's here. This h is the height of the prism. This h here is the height of the base. So remember, if you have to use a second color, it's referring to the base. So if we take that second color, our side work, base times height, our base is 25, and the height is 15, because I'm using this piece, this face right here as my base. So when I multiply that, we get that it has an area of 375 square feet. So we can take that and substitute it in here and take the height of the prism, which is 9. When we multiply this, we get that it has a volume of 3,375 cubic feet. So we just answered the volume of the prism. Now we need to figure out the volume in gallons. So here's our conversion. We have 1 gallon is approximately that many cubic feet. So if we make our chart, we need our cubic feet down here so they cancel out. And we know that this is 1 gallon. And we get that it's approximately 25,186.57 gallons. This should look familiar to chemistry. We convert the same way in chemistry as we do in class. We just got to get rid of our units of measure. So we answered the first question. Now we need to estimate the weight of the water. Well, we're going to take our gallons, because that's how much we have. And now we're going to use that second conversion that we were given. So we have 1 gallon weighs about 8.33 pounds. Our gallons cancel, so now we just multiply. I'm going to come over here. And we get that the density is about 209,804 pounds. So we can use volume to find the amount of space inside of a solid, but then we can also find how much it weighs or convert it to different units of measure. Let's take a look at cylinders. Cylinders, notice, still uses the same formula as a prism, but since our base is a circle, we end up having pi r squared h. So let's find the volume of this cylinder here. So notice we're finding the volume. We're given it's a cylinder, we're given a diameter, and we're given a height. Notice the height is not inside of this cylinder because the height has to be perpendicular to the base. Remembering this is also our diameter, which means our radius would be half of that, which is 9 inches. So our formula, area of the base times height, we got to substitute in our formula for area of a circle. So we come over here to do our side work. We get that the area of the base is 81 pi square inches. And then our height of the prism, remember, is 14. So now when we multiply those together, we get that it has an exact volume of 1,134 pi cubic inches. And since it said to leave in terms of pi, which I guess we should have highlighted, that is our answer. So now I want you to take a look at this one. So now let's look at how we change our dimensions. If the radius and height of the cylinder are multiplied by 2/3, so we're given a scale factor here, what are we wanting to find? We want to find the effect on the volume. So do we really even care about this picture here? No, because we know that if it's volume, we need 3 scale factors. Our scale factor is 2/3, so we have 2/3 times 2/3 times 2/3, which could be written as 2/3 cubed. So we have to cube the 2 and get 8, and we have to cube the 3 to get 27. So the new volume would be 8/27, the size of the original one. So now we can find volume of composite figures. So here we are trying to find the volume, and looking at what we're given this composite figure, which means we need to come up with a plan. So hopefully you see that we have a triangular prism, and we need to add a rectangular prism. So once you come up with your plan, now we can start doing the different pieces. So let's look at the triangular prism. The volume is area of the base times height. Area of a triangle is base times height divided by 2, and then times the height of the prism. So shade in the base of the triangular prism so that way you can keep it separate. You might even want to come down here and draw the base. So now we have this pink here, which means we inserted a new formula, so we need to do some side work. This base times height divided by 2. We know the base is 8. The height is this piece right here. Since it's an equilateral triangle, the angles are equal, and that does create a 30, 60, 90. So if this is 4, this is going to be 4 square root of 3. So we have 8 times 4 square root of 3 divided by 2 to give us 16 square roots of 3 square centimeters. So the area of our base is 16 square root of 3. The height of the prism is this piece that connects the two bases, which is 4 centimeters. And then if we multiply 16 times 4, we get that the volume is 64 square root of 3 cubic centimeters for our triangular prism. Let's do our rectangular prism. Same formula, but now for area of the base, we need to use the base times height, or length times width if you prefer. So our base and height on our rectangular prism, I'm going to use this right here as my base. So I just have 8 times 4, which is 32. So I insert my area of the base. The height of this prism is this piece connecting the two bases, so this will be 5. We get the volume of the rectangular prism is 160 cubic centimeters. Now remember, our plan was we had to add these together. So we want to add these two, and we could leave it as 64 square root of 3 plus 160 cubic centimeters as our exact answer. Since it says round to the nearest tenth, I can type it in the calculator, and I get that the volume is approximately 270 and 9/10 cubic centimeters. This last one you're going to do for class. So we're wanting to find the volume given the composite figure, You're given a radius of the big one, radius of the small one, and the height of the prism. We're trying to find this volume and round to the nearest tenth.